Welcome back to the channel. Hats on, boots are on. We are going to go back to the river because a few videos ago I asked, what would you want to know if we were at the LA River and could take any measurement? And one idea that continued to come up was, what is the water quality? And while there are a number of ways to assess water quality, one easy way, one way that we can all do is by looking at the total dissolved solids. And the idea is that we can measure the conductivity of the water and use that to estimate how much dissolved solids are in the water. Those solids can be salts, minerals, other dissolvable organics, and the more of those materials that are present, the higher the current, the higher the reading. And so what I'm going to do is use this total dissolved solids probe to measure the current, and it will automatically tell us the amount of impurities in the water. Now, the downside is that it won't tell us what's in the water, what's giving rise to a higher TDS value. However, it is a good step to understanding contamination broadly. So let me make my way down closer to the river and we will get started. This is the probe. It's fairly simple, pretty straightforward. There are 3 buttons: on, clear, and mode. If I open up the actual testing side, you can see there isn't much to it. There are 2 prongs in there, and as long as we have water that connects those 2, we can get a conductivity measurement. And so in a moment, I will be down by the river and we'll start taking some water samples. So the TDS values for a river and other large bodies of water can vary quite widely due to all the other sources that flow into the river. So if there's runoff from various rocks and mineral sources, that could raise the value. If there's pollution from various agricultural runoff, that could raise the value. But even just seasonal changes, the water level changes, the flow rates can evolve the number. And so this is going to be pretty interesting to see as we move to various parts of the river to calculate the TDS value. Okay, so here's an interesting stretch of river where we can see that on this side, it's a little bit deeper and still quite stagnant. And if we move to this area over here, it's quite shallow and we can see the sandy bottom. So this gives us an opportunity to pretty easily see how much the TDS values can potentially vary inside the river. And I will also try to get to an area that's flowing significantly more and see what those values look like. So let's get started. So to get started, you can see that we have a TDS value of 0. And to take the measurement, we simply just dip the probe in the river and wait a few seconds for the number to stabilize and we will have our reading. Let me show you. So the TDS value for this side, the deeper side but slow moving part of the river, is 577 parts per million, which is really high. According to the EPA, this would be considered contaminated water. And so let's move to the more shallow side where we perhaps expect there to be more contaminants. Let's get to a place where I can at least fully submerge the probe and take another measurement. So the slower moving, shallower side of the river reached up to 600 parts per million and would be considered more contaminated. So beyond the visible contamination we've seen in previous videos from the larger sources of litter, we are seeing signs that there are smaller contaminants that are also impacting the quality of the water. Notably, I probably should have worn some sort of bug spray, as I could tell there are quite a few mosquitoes over here, but science takes you places. So next, I'm going to move to a part of the river where there's a little bit more movement, where the current's higher, and see what that TDS value is. And when I get there, I'll let you know. This seems like a good spot to take another measurement. The water is pretty clear compared to what we saw before. It's moving pretty steadily, and we have a little bit of extra current here, so maybe this would suggest that this is a cleaner spot, but we have a way to measure it, so let's find out. Getting a reliable measurement when the water is this turbulent is difficult. When I looked at the probe was ranging between 200 and 500 parts per million, which overall does appear to be cleaner, but because of the high variability, as we already know, that's not a reliable measurement. So we need a way to capture the water. And fortunately, I did bring a sandwich bag with me. So what I'm gonna do is take a small water sample and then dip the probe in the stationary water that I've captured from this area and use that for my testing sample. So even the higher flow rate water in this area is still reporting as highly contaminated. It's still giving me a value in the high 500s, approximately 580. So on par with that first sample, perhaps not surprisingly, considering that area was still pretty shallow, despite looking a little bit more clear. But we'll take one more area a little bit further downstream and see what we find. Well, that doesn't belong there. So we're about 50 yards further downstream, and you can see that the water, again, looks more clear. Still a pretty strong current in this area. Let's see if it's enough to have a cleaner reading from this probe, or is this going to be much of the same as we had before? So this is what that experiment looks like when I suspend it in the bag, and the reading for this is also 580. So about the same as our first reading. And I'm guessing that would suggest that this is not enough turbulence to really clean up the water substantially. So we'd either have to go maybe further upstream of whatever sources, or an area where we have even more turbulence and perhaps a deeper pool of water. However, I want to show you what would be considered clean. And one of the cleanest sources of water, particularly if you're talking about TDS, would be certain types of bottled water. So, you know, if it's purified water or water that's undergone some sort of reverse osmosis, you would expect there to be next to zero TDS. So let's see what that looks like. I've got purified water here, and if we put this water in the bag, we'll see what the TDS value is for bottled purified water. Sometimes if they say spring water, the TDS values can be quite variable. But based on the claim that they make on the bottle, you should have a pretty good sense of what that value should be. The value might be a little bit elevated since I am using the same bag I just used to sample river water, because I didn't want to waste too many bags. So I'm gonna do the same thing. I'm going to submerge the probe in this purified water and wait to see what that value is. Or even in a bag that was dirty, when we pour purified water, we're only getting a value of about 15 parts per million. And I'm sure that'd be lower if I did not pre-contaminate the bag. And so this probe is a good way to determine how clean the water is, how clean your tap water is in your house. And this could vary significantly by state, by time of year, by virtually every factor you can imagine, depending on where your water is being sourced. I hope you enjoyed the video. In any case, I'll see you the next one. Peace. And yes, I wash my hands afterwards. Peace.